Hello everyone, thanks to be here today at our appointment focused on factor analysis. I'm Cristina Carini of sales staff at SPS, and together with my colleague Mattia Cefis, I'm really happy to introduce to the theme of today. Okay, this is our agenda, and I would like only to devote some minutes to SPS as a firm. As you know, SPS has been founded in 1994, and we are active on the field of statistical data analysis ever since. We are a business partner of IBM, and we take care of our customers from assessing the need of statistical data analysis, from choosing the most suitable solution of statistics for data analysis. We work with a lot of university, international foundation, healthcare association, and so on. Today, we are really proud to announce that we have signed another long-term agreement with the World Food Program for the next 3 years. And we are very happy to collaborate with such as a foundation. Why do we talk about statistics for data analysis as a solution? Statistics for data analysis is a solution because we had to the core of SPSS a lot of tools to share our knowledge in statistical data analysis. The first tools that I'm happy to introduce you is the Launchbox. Launchbox is a dashboard, is a gateway to our world, because we keep in touch with all our users, with our proposal, with the event that we suggest, like today, of course, or training or new functionalities, premium modules, and all the tools that we found to share our knowledge, because this is one of the first goal in our activities. Downloading Launchbox, you download in the same time add-ons. Add-ons are additional features that give you a smarter way to use the solution. We have developed 2 premium modules too, P-Score and Uden, and now we are working on a new premium module and on new add-ons that I will introduce you at the end of the appointment. Okay, one of our last project about learning resources is Starter Pack. Starter Pack is a new repository where you can find a lot of tools for your training. And we decided to work on it thanks to a suggestion of some customers. Here, our users could find manuals, data sheets, and for example, Statistic Express video pills that we share with our users in the last months. Okay. Now it's time to Mattia. Mattia is one of the most valuable trainer, and I'm very happy to give him the stage of this appointment to figure out factor analysis. Thank you very much, Mattia. I think that my colleagues are giving you the role for sharing your presentation.
Yes, thanks a lot for your presentation, Cristina. I'm sharing my screen. Okay.
Okay, I see your presentation.
Perfect.
Okay, thank you very much, Mattia.
Thank you to Cristina. So good morning to everyone. I'm Mattia Cefis, a trainer of statistics of SPSS, and today I'm very glad for being here and presenting you this webinar, this part of related this statistical tool, very important, as factor analysis with statistics for data analysis. In our agenda, we will have a different step. Starting from an introduction, I will give you an idea about this tool, the objective of this tool, when we can apply factor analysis, and after that I will show you a practical example directly on the software. But let's begin. I show you starting from this slide. In this slide, I tried to summarize the major part of statistical techniques available in literature. And as you can see by the green rectangles, you can follow the way, the path to arrive to the factor analysis. Factor analysis belongs to the unsupervised statistical learning methods. Differently than the supervised methods like linear regression and logistic regression and many others, in which there is a target variable, while factor analysis is so-called an exploratory analysis. In fact, there aren't any target variables, but the aim is to explore the data, and in particular, if there are any patterns among variables. Okay, it is similar but not equals to the PCA, the factor analysis, and it is a very important tool, in my opinion, to discover, to develop about any relation among variables in our data sets. But let's move on and try to understand better this topic about the factor analysis goal. First of all, the goal of this statistical tool is to reduce the number of variables in order to find some latent variables. And for example, they are called factors in this tool. So factor, there are latent variables not directly measurable. Okay. And the second main goal of factor analysis is to maintain a high level of explained variability at the same. So the objective is to lose just a few variability and try to explain the maximum possible of it. So this is a double goal for this statistical tool. And by some statistician and mathematician algorithm, it serves to reach this goal. And as I introduced in the previous slide, the difference among the observed or measured variable, the measured variable, as you know, since you work with variables from a data set and so on, those variables are that ones that can be directly measured and or detected by a survey or by measuring trial and so on. For example, the age, the income, and many others are so-called directly measured variables or observed. While a common factor, so a latent variable, these are features, it is a characteristics that cannot be directly measured, but it is there is an hypothesis that this common factor links with other observable variables. Examples of common factors can be the intelligence, the culture, unconscious, and many others common factors that are not directly measurable. Okay, it does not exist a variable that measures these concepts. Okay, but there are a set of items, okay, that can measure these this complex concept. Okay, this is the very important topic to understand. So the factor analysis try to capture, okay, these latent concepts, okay, based on a set of items, okay, and we try to make emerge, okay, this latent concept or common factor. It is synonymous. And but the main question, okay, we saw in the previous slides, okay, the objective of factor analysis, okay, the idea of directly and unobservable factor, but when can we use, okay, factor analysis? When there is quite a good presence of correlation among the initial items, the initial variables we have. Okay, so if there is as a starting point, a correlation, a quite good correlation, it can be a good signal, okay, to apply factor analysis. Then there are two interesting tests and statistics available on SPSS. So the Kaiser-Meyer-Hölking statistics and the Bartlett test. Based on these two values, we can detect if our dataset, our data, are okay to apply factor analysis or not. Okay, this is very important. And an example of concept, latent concept that make emerge the items, okay, is the satisfaction. For example, we try to measure the satisfaction, okay, in the tourism for one hotel, for example. The satisfaction, okay, is the concept is clear, okay, and this okay, this common factor, let's say, emerge from different items that we can obtain from a survey, for example, from different sentence like I appreciate this hotel, the food is good, I can't wait to stay in this hotel again, I feel comfortable, and many others. So the concept, okay, is reflected by these items. So in fact, in the factor analysis, the indicators are so-called reflective, since from the latent, the arrow start from the common factor and move to the items, like in this way. In fact, removing one item does not change the nature of the underlying concept. So if we remove one item, the concept of satisfaction, it still remains, okay? And this concept generates the corresponding manifest variables, for example, also for the intelligence test and many others ones. So in the case of the survey, this is the situation in which we could try to apply factor analysis. It is very, very interesting, this kind of approach. Just a few words related to the theory underlying the factor analysis in our agenda. And in particular, factor analysis is based on some objectives, of course, mathematical and statistical objective. So it is a sort of iterative algorithm that tries to reach a convergence, okay? And it models the original variables as a linear combination of a reduced set of unobservable latent random variables called common factors. The objective is, the mathematical objective is to maximize the communality. Communality is the proportion of variance in a variable, okay, that is shared with the common factors. It indicates how much of the variable's variance is explained by the underlying factors extracted in our analysis. Of course, higher is the communality, the better is the the factor, okay? The better is that variable represented by the factors. Okay, this is the idea behind. And the third objective is to minimize and explain, of course, the residual variability. This is the mathematical objective that follows the factor analysis, okay? And by other example, I show you an example with 3 explanatory variables. The idea behind is that there is a common factor here in the rectangles with capital F that reflects the items I call the x1, x2, x3, and the factor analysis estimates these weights B1, B2, and B3. Okay, and in particular, then there is, since it is a statistical model, there is also the error term called spherical factor, and the weights B1, B2, and B3 are calculated by OLS, and very interesting, in opposites than the PCA, the outcome here is the item. The item is x1, x2, x3, and the factor here is here as a sort of independent variable. Okay, this is the difference. Then the PCA, in which the arrow starts from the item and goes to the component, principal component, and move to the principal component. This is the opposite situation. But more interesting and directly on our approach, are the data suitable for applying factor analysis? When I introduced in the previous slide the concept of correlation and the 2 tests, the Kaiser-Meyer and the Bartlett test. We can say, okay, I apply the factor analysis if the Kaiser-Meyer working test is greater than 0.5, sorry. And if Bartlett's sphericity test is significant. So if we have a very small p-value, lower than the cutoff. And again, if the extraction communalities are greater as a prudent approach, greater than 0.3. Based on these thresholds, we can say, okay, it is a good idea to apply factor analysis, and we can move on. Okay, but I will show you in the practical example directly on the software. Just a few things again before moving to the software. The criteria for choosing the appropriate number of factors, it is important. The second very big important things to explain. The criteria are, there are more than one criteria. The first one, the most used, if the Higgins value is greater than 1. Or again, if the cumulative explained variability is greater than 60-65%, more or less. Again, another criteria is to follow the elbow of the scree plot. So the scree plot is a graph like this one. It shows on the x-axis the factor, the number of factor, in the y-axis the eigenvalue corresponding, and of course it is a decreasing function. And in particular, if it is clear, like in this case, the elbow, we will choose 2 factors in this case based on these criteria. Anyway, the most used criteria is based on the eigenvalue greater than 1. But it is, I show you this criteria too, that it is interesting. For a better interpretation of the factors, of course, so after the factor analysis, another, the last step is to give an interpretation to each factor, to each latent emerging factor. And for a better interpretation, we can adopt a Varimax rotation that maintains orthogonality, of course, the independence between factors, and we can read the so-called loadings as a sort of correlation index for the interpretation, their interpretation. So we can say that a variable is significant for that factor, for one factor, when the loading is maximum with respect to the other factors. And generally, if it is greater than 0.4 more or less. This is the most used criteria for the interpretation and to give, because the final objective is to give a sort of a label, okay, to each, a name to each latent factor. And since it can be a starting point for further analysis, this exploratory approach. But now I move to the software, to statistics for data analysis, for an example that I show you. I move out from here and I move here on the software. I can, of course, we can launch the software from the dashboard by this button, launch, of course, as introduced by my colleague. And this is the dataset I propose you today. Today it is a dataset that contains data related the fire about different more than 100 zones of the Portugal. If I move to the variable view, we can see the label. Okay, we have 6 items coming from a survey. Okay, to the population. The first one is the perception of humidity in the days prior to the fire, the perception of humidity during the fire, the perception of the fire spread, the perceived temperature, the risk perception for objects and animals, the risk perception for people, based on these values. So it is, in this case, the results coming from a survey. We have the area corresponding and the ID. We can apply factor analysis because we have ordinal data. Factor analysis can be applied with quantitative variables and with qualitative ordinal variables too, like in this case, coming from a survey. So in which of course, there is an agreement from a scale from 1 to, in this case, from to 5, okay, related to perception. The first thing to do is to have a look to analyze the descriptive statistics based, for example, the analyze descriptive statistics explore. We can have a summary about the statistics for each variables. We can show to see, in case, the histogram, and we can also have a look. We have a summary to give a summary about the main inferential and descriptive statistics for each variable. In case here we have for each variable to the histogram and the box plot, and so on. Another interesting thing is preliminary analysis. We can, by the analyze descriptive statistics, to explore by area as a factor, for example, in order to have a look. In this case, I show you just the plots just for simplicity. So in this case, I stratify by zone, by area, center, north, and south for each variable. It can be as a starting point to have a look about the data stratified by area. But the idea is to try to apply a factor analysis in order to reduce the number of items and explore if, since it is an exploratory approach, to explore if emerge some common factor, okay, behind these items, okay. This can be the idea, and use, since it is a starting point, use them as, for example, for in-depth analysis by area, for example, in order to show maybe in a plot, in a bidimensional plot, it emerge some pattern by area, for example. But first of all, I analyze the correlation. Remember the slide by the command analyze correlate by variates. I select our ordinal variables. I can set to show only the lower diagonal for in order to have a clearer visualization. I launch the command, and I have a correlation matrix. So in order to have a preliminary analysis before the factor, in order to see if it emerges some significant correlation among the items. It is helpful in this case by SPSS because it suggests us the correlation significant by the asterisk, as you can see here below in the legend. And in particular, we can see, for example, a significant correlation among the perception of humidity in the days prior to fire and during the event, 0.3. A low correlation, but significant, because we have a very low p-value. Also, in these cases, there are many asterisks, and so the majority of these correlations are significant. So it means there is a sort of links among these items. So we can try then, of course, during the approach of the factor analysis, we can have a look, of course, to the test, to the Bartlett test, the test if this matrix is significant or not, and the Kaiser-Meyer-Hölking value. Remember in our slide here, if the Kaiser-Meyer-Hölking test is greater than 0.5. Now we can try to apply and set the factor analysis. Okay, I try to adopt this strategy. So by the analyze, okay, dimension reduction factor. Okay, this is the box for factor analysis. I have to move here in the blank section all the variables I am interested. So from the perception of humidity to the risk perception for people. And now we have to set the options by these buttons. First of all, by the descriptives, there are many options, but the most important is to check the Kaiser-Meyer-Hölking and Bartlett test here. Then we can have a look also to the initial solution, and it is okay. I click continue. Extraction. The button extraction, in order to set the method to extract the factors, not principal components, but unweighted least squares for factor analysis. I have to set. Then I have to check here the scree plot. Okay. In addition, here, have a look. By default, it extracts the factor based on eigenvalue. So eigenvalue greater than 1. And it is okay for us. Again, since it is an iterative procedure, here below it is set 25 as maximum iteration for convergence. Generally, it is okay. This value, it keeps less than 25 iteration, but just for being sure, I can add here, for example, a 0. Anyway, it reports an error message if this number of iteration has exceeded. Anyway, I click continue. It is okay, this set. Then rotation, okay. Remember, by this slide, the rotation, it is important for interpretation, okay, of the common factor. I select Varimax. I let the other options by default. I can display the rotated solution. It is okay. Also this normalization. Also in this case, the iteration we can change. We can add a 0 just for being sure. I click continue. Then for the moment, I don't set anything here in the score because it is the first exploratory approach. And first of all, we have to understand if these data are okay for factor analysis or not. And so I click OK. Let's run the procedure. And here have a look on the output. The first table is the most important because based on this table, we have to choose if move to go on for the other output or not. Since it is the Kaiser-Meyer and Bartlett's test table. So first of all, have a look in the top right of this table. We have the Kaiser-Meyer walk-in measure. It is medium height. It is 0.66. It is good. It is greater than 0.5. We are happy. And again, the Bartlett's test of sphericity is we have to read the significance, the p-value in the bottom right of this table. There is a very, very low p-value. Okay, so it is okay. So these data are okay for applying the factor analysis. And so let's move on. Here in the second table, there are the communalities. Communalities, in particular, we have to read the communalities in extraction, so in the second column. So in this case, it's all the variables have a communality greater than 0.3, except the last one, but it is 0.2. It is not so low. So are quite good as scores in extraction, the communalities. And then we can move on and read this table named total variance explained. In particular, in this table, we have to read just the left part we are interested in. In particular, the column named cumulative percentage of variable. In this case, it extracts two factors. Okay, since they have a eigenvalue greater than 1. In particular, the first factor, its eigenvalue is 2.492. The second factor, its eigenvalue is 1.327. So in this case, we extract two factors. So the first two factors extract the 63% of cumulative variability. It is a quite good value if we recall here the criteria for choosing the appropriate number of factors: eigenvalue greater than 1, then cumulative explained variability greater than 60%. And so in this case, we extract two factor. Remember, we had 6 items at the beginning. Here, the scree plot, it is not so clear, the elbow of the scree plot in this case. And let's use the first criteria based on eigenvalue. It is the most used, and also the cumulative variance. So we extract two factor. It is okay. Then here SPSS proposes in the output again the factor matrix, and but we are interested in the rotated factor matrix based on the rotation that converges in 3 iterations, very fast algorithm. We have two factor, and how we can read this table. We have inside this table the loadings, and remember, if loadings are greater than 0.4, okay, it means that this item is important, strictly related to that factor. For example, the first factor, let's have a look to the first column, is so related with the first 4 variables. The loadings are high, 0.5, 0.59, 0.729, 0.7, while the second factor is strictly related to the last 2 items. As you can see, the factor analysis try to this rotation try to maximize the loadings of each item for a given factor. Okay, so if we have a look, for example, this the risk perception for objects and animals has a loading very low for the first factor, 0.175, and very high with the second one, 0.992. Okay, so we can summarize the first factor, and we could call the first factor as the environment perception, to give it a label, and while the second factor we can call as a risk perception. It is strictly related. So now the last step, once we detected the factors and give them a label, an interpretation, we can save in our dataset these factors, scores. Okay, how can we do it? We can repeat the analyze, dimension reduction factor. Now we need this button, this course, and we need to save as variables the two factors we are interested by the Bartlett method in this case. So save as variables, method Bartlett, continue, let's run. The output is the same as the previous one, but in this case we have the two factor scores saved in our data set. These two new columns, fact 1 and fact 2, we have to move here in the variable view, and we can here give a name F1, F2, and here in the label we can call the first factor as environment perception, and the second one the risk perception. So it is useful, first of all, because if we for the successful analysis, okay, and another important thing, because now we save the dataset, and if we reopen the dataset in the next 2 months, 3 months, 1 year, we arrive here and we have the description, the label, and so we can remind what means this that specific variable, and we can remind it. So now it is interesting. I have a first analysis, for example, to have a look, okay, by a bar plot, these two factors, for example, stratified by the area, in order to see if there is a pattern, okay, among the area. I recall you that these scores are standardized scores by F1 and F2. It means that these zero values very close to zero, it means they are on average, okay? For example, in this case, the environment perception values greater than zero, it means that there is a very high environment perception related to the scores, so humidity, temperature, very high, and vice versa. And the same for the risk. Let's try by a graph, in particular by a bar plot. Let's try a clustered bar plot by summarizing of separate variables. Let's define. And I put here the bar represents the mean of each factor. The category are represent the area. I click OK, and here we have it is a first very easy analysis based on the area, and these are the means, of course. In light blue, there is the environment, and in the dark red, the risk perception. As you can see, the center, the north, and the south, rectangles greater than zero mean values higher than the average. It is zero, the average, since this represents standardized values. Pay attention on the scale. These are very compact values because the minimum is minus 0.15 and the maximum is lower than 0.15. So they are so compact values. So it does not emerge very insignificant differences among areas in this case. And in particular, you can find the procedure for to replicate this bar plot by graph bar clustered, and summarize of separate variables, because in this case we had two quantitative variables, factor 1 and factor 2. I show you a last plot, interesting. In this case, we can see the scatter plot again by if in order to see if there is a pattern among area. It does not seem, but let's have a look by this in-depth graph, in particular by graph scatter plot. The simple scatter, I define the F1 as x-axis, F2 in the y-axis. I can set marker by area, and now I click OK. And here we can see, of course, the environment perception on the x-axis and the risk perception, the y one. We can, in this case, that does not seem there is a pattern because colors that represent the areas are mixed. It means it does not seem to be a pattern among the area. I can add, for example, a vertical line corresponding to the zero, because the zero represents the mean, the standardized mean, also for the horizontal, in order to give maybe a greater idea. And but of course, greater than zero, it means higher than the average, and vice versa for both the factors. In this case, there is not a pattern among the area, but it can be in any way a starting point for further analysis to use F1 and F2, for example, with a regression analysis if we have a target variable, an outcome, and so on. This is an exploratory analysis, this factor analysis that help us to adopt it. The last thing before coming back to the slide and conclude, I show you this interesting add-on as introduced by my colleague before. By the data, it is interesting to split into files if we have a stratified data set, like in this case, stratified by center, north, and south. If maybe we are interested to separate the data set and focus on a subsample, for example, for the analyze this only the center, the south, or the north, we have to move to the data, and the add-on is called split into files. We can split cases by area in this case, and we have simply to set the output file, the directory, for example, the desktop, save, and then if we click OK, it creates on the desktop 3 new files named north, center, and south, just as a little in-depth analysis. I come back to the presentation, and I conclude by this slide by summarizing what I explained during this webinar. So the factor analysis, it is okay with quantitative or ordinal variables, ordinal qualitative variables, like our examples by the survey or questionnaires, coming from questionnaires, or again, it is okay when there are relevant correlations are present among items, when explained variance is greater than 60–65%. The main goal is the dimensionality reduction to make emerge these common factors, and it is an exploratory analysis, so it is a starting point for further analysis. So that's all. I hope you appreciated my presentation, and if you have any questions, I am available.
Okay, Mattia, thank you very much. We have received some questions, okay. And then I take the question from the chat. The first one, could you please repeat the procedure for the bar graph?
I already told you during the
okay, thank you very much. Sorry.
Yes, you're welcome.
Okay, the other one. What if the KMO Bartlett and communalities don't give the same result? Which one to consider?
Thanks for the question. The main is the Kaiser-Meyer, as hierarchical choice. But my suggestion in that case is to try to have a look to the data, and in case try other procedures, and go on without applying the factor analysis, because it is better if all these values, the KMO, the Bartletts, and the communalities are greater than the threshold. It is better, in my opinion.
Okay. Another question. Do the variable need to be numeric, or can I use a text variable? How many categories can the variables have? Can they be 20 or 30?
Okay, thanks for this other question. We can use, for applying factor analysis, also categorical variable, but ordinal variable, not nominal. We can use if they are ordinal, also if they have 5, 10, 20 categories. It is okay, but they must be ordinal. Okay. For nominal data, we can't apply factor analysis, but other techniques.
Okay. I suppose the last one, can I handle missing data in factor analysis? If yes, how?
Of course, missing data, we have to treat them before in the let's say zero step. Let's call it, when we treat with the data, when we are knowing the data, the data set, and my suggestion is to treat the missing data first, then applying the factor analysis. Thank you.
Okay. Okay. In the chat, we received some other question about the difference between factor and PCA. We have decided with the training staff that we prefer to answer via email because we need
Okay.
more than 1 minute to answer. And okay, there are another one. If you, are you able to read it, Mattia, in the chat?
Let's okay, let's have a look now.
Thank you very much.
You're welcome.
Because if the question are too tough in order to answer now, we will answer via email in the
Yes, the main
next
difference,
days.
just the first one, the difference between factor analysis and PCA. Factor analysis is preferred to treat with survey data when we have questionnaires and we want to make emerge some concepts like psychometric concept, like I introduced in the presentation. While PCA, it has a different approach, and it is better to create some composite indicator, the PCA, when we have generally quantitative variable, not coming from a survey. This is the main macro difference.
Okay.
While I can now just one thing, Cristina, just have a look at the other question.
If I well
If
understand,
we only have to choose the factors that present the eigenvalue greater than 1 in the matrix. Would it be an error to choose even a third it has a value greater than 1? We have to choose if we have 3 factors, 4 factors, 5 factors with eigenvalue greater than 1, it is okay. We have to choose those numbers. So this is the main criteria. In our example, we had just 2 factors with eigenvalue greater than 1, so we decided to lower than 1. Lower than 1, it depends. If we have a look to the cumulative percentage, it depends from the situation. Of course, if it is close to 1, 0.9, for example, we can try to choose a third factor in that case. For example, when the cumulative, if it helps us to reach the threshold of cumulative variables of the 60%, for example.
Okay. Okay, I think that we are at the end of the appointment. Thank you very much, Mattia. Now I only share our last some other information. Okay, thank you very much for your attention. We hope that the information that we have shared with you could be useful for your daily work, and we are at your disposal. If you have any question, please keep in touch with us via email in order to answer to you. What next? Okay, We are working on new add-ons that our user will have ready for downloading in the next weeks. And we are very glad that we are preparing a new premium modus too about robust regression that will be available with version 30. Okay, next webinar will be in Italian mother tongue in May about propensity score matching, and we are always very interesting in having your feedback about new theme for the next webinars to set in our agenda. Talking about feedback, please fill the survey that we are going to send you in order to set our webinar with your need in statistical data analysis activities. Okay, thank you very much for your attention. We hope to have give you interesting information, and if you have any needs, please keep in touch with me or with my other colleagues. Have a nice day.
See you. Have a nice